So this is supposed to be a drawing of a spring. So there's a spring in there. This is a piece of like string on there. And the string breaks and this thing pushes them apart.
So if you're going a sound effect on the left-hand side, it's like, because it wants to break apart.
Do the right-hand side.
And then the right side, boing.
Okay, good.
And so then they fly apart. Now, we got an easy before momentum because
nothing's moving.
Yeah, and now the combined mass of those things would be 30, but 30 times 0 is still 0. So the momentum before is nothing. And
is 0, yeah.
Let that be a lesson to you, boys and girls. If everything's still before the problem, there is no momentum before. So you just set it equal to 0 and we're good to go. Now we got 13 times of velocity we don't know. And so therefore, even though I would imagine that the answer will turn out negative, you never presuppose that. Just put a V.
Put a V there.
And let the math work its way out. But we do know to the right is positive. So we got 17 times 3.6. 17 times 3.6, that's looking at 61.2. So you got 0 is 13 times V plus 61.2.
So this has got to be negative to make it 0, right? Because that's a positive.
Yeah. So our first step is going to be to subtract 61.2 from both sides. We don't want any bad algebra here. And so 61.2 negative divided by 13, we're going to get negative 4.7 meters per second. And so as we thought, it's going to go off to the left. And it's going to go a little bit faster to the left than the one is to the right. Why do you think that is, kids?
It's got less mass. So it's got to go faster to have an equal but opposite momentum.
You are truly a gentleman and a scholar, Mr. Murray.
I know. I should have a degree in physics.